Hi Josh. So this is some pretty simple geometry once you know what's going on here. So in your first angle pair, they're asking you for angle PNL, which I've highlighted in yellow here. P, N is this point, and L means that we're looking at this angle. And angle PNL forms a 180 degree angle with this 64 degree angle right here, LNQ. So we can say that angle PNL is a supplementary angle with angle, what did I say, LNQ, which means that angle PNL plus angle LNQ equals 180. So if I know that LNQ is equal to 64, which they show me here in my diagram, then I can replace LNQ with 64 and say angle PNL plus 64 equals 180. And then I can use, excuse me, I can use inverse operations to solve. So plus 64 means I'm going to do minus 64 to cancel that out. And 180 minus 64 is 116. So therefore, angle 116, or x, as they're asking us the degree measure there, 116 equals x. So the measure of angle PNL is 116 degrees. All right, so let me know if you have any questions still on number one. Number two is pretty similar in that angle MSW, or WSM as they name it here, and HSW, they also, these two angles combined right here, add to a 180. So it's going to involve a little bit more math here, as they don't just give us a number like they did here. We've kind of got to figure things out for ourselves here. So to find angle WSM and HSW, I'm going to combine these two expressions here, 8x plus 4 and x plus 23. I'm going to combine those, and I'm going to set them equal to 180, because these two angles right here make this straight line and cover all of this space of 180 degrees. So it's going to look something like this: 8x plus 4 plus x plus 23 equals 180. See here, I have this angle, so I'm counting this one, and I've included this angle, so I'm taking care of this whole thing right here that, as we said before, was 180 degrees. So 8x plus 4 plus x plus 23. I can combine some like terms here. So let's see, I'm going to add 8x plus x. This has what's known as an invisible coefficient. So if you see an x alone, remember that that's 1x. So 8x plus 1x would equal 9x. And I can add the 4 and the 23. So 9x plus 27 equals 180. And here again, I use some inverse operations. So minus 27 on both sides. We'll cancel this out, and 180 minus 27 will tell me what this 9x right here is equal to. So 180 minus 27, let's see. So 9x is going to be equal to 153. So let's do some long division, because if I divide by 9 on both sides, I'm going to have the value of x, which I'm then going to plug back into these two equations here to find out what these two angles are. Okay, so just to recap, we combined these two expressions here. We said, okay, they equal 180, and then I just started solving this equation. Now I'm dividing, and then I'm going to find x, and I'm going to then take the value of x and put it into both of these expressions here. So we're doing 153 divided by 9. 9 goes into 15 one time, and that's 9. 15 minus 9 is 6. 9 goes into 63. 9 times 7 is 63. So it looks like x equals 17, but we're not done yet, because now we're going to have to take this 17 and we are going to replace this x with 17, and we're going to replace this x with 17 so that we can find out what these numbers are. Keep in mind that this is 8 times x, so now this is going to be 8 times 17 plus 4. So if I do 17 times 8, that's 136. 136 plus 4 equals 140. So the bigger angle, angle WSM, is equal to 140 degrees. And angle HSW is 17 plus 23. So that's 40. And if you look, angle 140 and angle 40, of course, when I add those two together, I get my 180 degree angle. All right, so to summarize everything, we put these two together to create a 180, solved the equation. We found that x was 17, and then we took the value of x and we substituted and solved these two expressions to find our angle measures. So whenever we do geometry, we also do quite a bit of algebra. Now, this diagram is a little bit different in that we're trying to find angle ATK, which is this one right here, and JTP, so this one right here. And these two angles are not supplementary. They don't form a 180 like the angles that we looked at previously. So what these angles are known as is actually vertical angles, meaning that they lie diagonally to one another. They share this intersection right here, and being that they are formed by cutting a line with the transversal, and these two right here will add to 180, and so will these angles have exactly the same measure. So what I'm going to do here is kind of similar to number 2. I'm going to say, okay, 10y minus 7, but I'm not going to say that it's equal to 180 with this one like I did last time. Instead, I'm going to set these two expressions, equal to each other because they have the same exact measure. So if I just start solving this equation, I'll find the value of y, and then we'll do like we did last time and substitute our value of y in both expressions. So using inverse operations, I can add 7 here to eliminate that from this side of the equation. 49 plus 7 is 56. If I could write it correctly, 56. And I can subtract 3y from this side to say that 10y minus 3y, 7y equals 56. And then since this is multiplication, if I divide by 7 on both sides, I see that y equals 56 divided by 7, which is 8. All right, so now that I know that y equals 8, I can come back to my expressions here, and I can substitute 8 for y in this expression. So I'm going to do 10 times 8 minus 7 for ATK, and I can replace this with 8 also. So for angle JTP, I'm going to do 3 times 8 plus 49. All right, so 10 times 8 minus 7, 80 minus 7 means that angle ATK is 73 degrees. And 3 times 8, 24, plus 49 equals, should also be 73 degrees. But we just checked ourselves with actually adding the numbers, so 73 degrees for JTP as well. So knowing that these two are vertical angles, they have the exact same measure, everything fits, and we have proved that both angles are 73 degrees and that they are vertical angles and have exactly the same measure. So let me know if you have any questions about 1, 2, or 3, and just let me know how your assignment goes.